All right, so for this one, it says a cart is placed on a frictionless inclined plane with a height of 4 feet or 4 meters. What is the length of the inclined plane if the cart has an acceleration of this much? 4.7 meters per second squared. So now, remember, what's the first thing we do when we solve a physics problem?
Draw a picture.
We're going to draw a picture. All right? So an inclined plane is a ramp, and the height from here to here is 4.0 meters, right? What they want to know is this length right here. And they said that the cart, this is my cart, a perfectly drawn cart. That's the window. That's the door. Anyways, that thing is going in this direction that has an acceleration of 4.7 meters per second squared. All right, so now we got to figure this out. I think what we need to do is we need to think of a couple of things. One, it'd be nice if we knew the angle here. We don't, though. Also, we have to think in terms of the xy plane. So I could also rotate my xy plane like this, where this is x, and this is my y-axis. Remember this from our notes? And basically, I'm going to have to figure out, what do we know? This is what we know from the problem. What else do we know? What's really causing the cart to go down the hill? Gravity. So what's the acceleration due to gravity?
9.8 meters.
Yeah, going straight down towards the center of the earth, right? So gravity is going down in the negative direction, 9.8 meters per second squared. Okay? So if gravity is going down and I have an acceleration going in this direction, right?
Good afternoon. We have your bus information. Bus 102 will not.
So now that I know that sine of theta, because I don't quite know what theta is, but I can find it. Sine of theta is equal to 4.7 meters per second squared over the 9.8. And this is the hard part about this, is your triangle. Remember that SOHCAHTOA sine is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. So if I say sine, if I say arc sine of 4.7 all over 9.8, that will give me theta, right? So this is just basic geometry. And I could plug that into my calculator. We'll just do that in Desmos real quick. .7 divided by 9.8. Oh, I hit the wrong thing. We got to do arc sine, right? So let's clear all this out. Arc sine, of 4.7 divided by 9.8. All right, whoops, 9.8. There we go. Oh wait, we don't, you know what? We don't even need the angle, right? So let me back up a second. I really just need to know the value of sine, right? So really, I don't even need to know the angle. I just need to know the value of sine. And so I could just take 4.7 and divide it by 9.8, and that'll give me sine of theta.
Got a question.
Yeah.
Nope. Can't you just do like just do the height divided by 4.7 divided by 9.8 to get an answer?
That's what I'm doing right now.
Oh, for real?
Yeah.
Okay.
I had to think about it. I was gonna find the angle and then plug the angle back in, and then I realized I don't really need to do that. So then the length of the inclined plane would be equal to, so this is a different triangle. So the length of this would be essentially equal to the height, right, times sine of theta. Because, so it would be equal to 4.0 meters divided by sine of theta. And I was going to solve for theta and then plug it back in, and I was like, I don't even need to do that. And so this would be 4.0 divided by 0.4, whoops. The 0.480 and then that would be what value is that? If I plug that in a calculator, I think it's about 8.3. All right. So we'll say 8.3 repeating meters. Now, I don't know. I probably, if we were to find the angle theta, this is another way you could have done it. This would be 4. So this would be what? The opposite? What would this be? The hypotenuse. So if I plug this in and I figured out what theta was, which if I remember was like 28 degrees or something like that. If I do that in degrees, it was like 28.67. So we could say that this is 28.7. You still end up doing the same thing. So that would be the opposite over hypotenuse. In other words, sine of 28.7 equals the opposite, which is 4, divided by the hypotenuse, or the hypotenuse is the length. So I kind of glossed over that. Okay, and so from there, that's how you get this stuff. And I was saying, well, you don't really need the angle; you just need to plug in the value of it, right? Because sine of 28.7 is equal to 0.480. Okay? So that one's a little bit confusing because there's a lot of steps involved. Does anybody have any other questions on that? Probably, yeah.